packet that I had you guys grab from the front. And what it's going to do is that it kind of breaks down for you all the different steps and ways that you can use Desmos, at least on the Math 1 exam. All right. And I went downstairs and printed in color for you guys so you can get the full effects and all that loveliness. All right. So let's go ahead and look at the first part of that packet. So the very first thing that you can use Desmos for, that you probably didn't think you could use Desmos for, is to actually solve equations. All right. So when we're talking about solving equations, that's like having 2x plus 1 is equal to 3 or anything of that nature. All right. Or if you're looking at this example here, this is the one that they actually have graphed. 2x plus 3 is equal to 2 raised to the x power. Now, when you graph into Desmos to graph an equation, you can't just type in the entire equation into one slot. All right. You're actually creating a system of equations and solving that way. So what you do, your steps are right here. So the first thing you do is type y equals on the left side of the equation, y equals on the right side of the equation into Desmos, and then find where the equations overlap. In other words, you're finding the points of intersect. Now, since you're dealing with the point of intersect, the point that you want to use the x value. Why do you think you guys want to use the x value if you're solving equations as your answer? What are we typically solving for when we solve an equation? So guys, when we solve an equation, what do we typically solve for? What variable? X. So that's why you use the x value of the point. Because remember, with a system, you get 2 points. You get the x value and the y value. But we only care about the x value. So, for example, the one that they have graphed here, they took this equation and they took the left side of the equation, set it equal to y. They took the right side of the equation, set it equal to y. And it created this system over here. Now, we know that if we're graphing a system, we always find the points of intersect. So they intersected here and here. Now, when you're looking at the points, your answer is your x values of the point. So this would be one of your answers. This would be your other answer. So this is one where it has 2 solutions. All right. So regardless of how simple or complicated your equation is, if you have any doubt in your mind about solving that equation, plot that sucker into Desmos and find the points of intersect, use the x value. All right. It doesn't have to be a system in order to use Desmos to solve it. You can make it into a system. All right. So, like they just said, the solution is right here. It's their x values. Those are their solutions. Now, I'm going to show you how to do one of these as an example, and then the other 3 I'm going to let you guys try out. All right? So let's do letter A together. So first things first, I'm going to take, using my equal sign as a guide, I'm going to create the system of equations. So I'm going to take the left side and set it equal to y, and I'm going to take the right side and set it equal to y. So what I'm putting into Desmos is y equals x minus 2 in one column, and y equals x squared minus 2x minus 3 in another column. That's what I'm going to type into Desmos. So take a minute, go ahead and type that in. So I have y equals x minus 2 and y equals x squared so x squared minus 2x minus 3. All right, so this should be the screen that you see. So the red line is the x minus 2, the blue is the quadratic graph. Now, remember, Desmos already goes ahead and marks the points of intersect for you. So you can just click on them. So here and here. So what would my two answers be? What part of those points do I use? X. So my two answers would be negative 0.303 and 3.303. All right, I'm just using the X values. We don't care about the Y values in this situation. So my answers is X is equal to negative 0.303 and 3.303. Now, remember, you need to type in both sides of the equal signs exactly as you see it. All right, if it's not exactly as you see it, it won't work. Any questions on that? So what I want you guys to do is take about a couple of minutes, find the answers to B, C, and D. So use Desmos, find the answers to B, C, and D. So everyone needs to have their heads up, and they're using this. Everyone needs to be putting this into Desmos. So you're finding the answers to B, C, and D. Some may have more than one answer, so be careful about that. Make sure you get all the points of intersect. Some may have one, some may have more than one. So again, be careful. Make sure that you type it in exactly as you see it. All right, thumbs up if you're ready. Give you guys one more minute. So I want you guys to find B, C, and D. All right. So, Caroline, what'd you get for letter B? So you got it graphed. What was the point of intersect? All right. Riley M, help her out. What'd you get for letter B? All right, I'll come back to you. Riley E, what'd you get for letter B? Right, x equals 1.8. So there was only 1 point of intersect, so that would have been the answer. All right. Riley M, what'd you get for C? Say one more time. Yes. What did I graph that? Oh, yeah. That would do it. Yes, you are correct. 1.248. All right. Now, Brian, what is one of the solutions that you got for letter D? Good. Ben, what's the other solution you got for D? Didn't do D yet? All right, so let's do Ralph. What's the other answer you got for letter D? 1.264. Good. So that's exactly what I got. Now, just to recap what we know about solutions, what happens if the lines don't intersect or the graphs don't intersect anywhere? It's no solution. All right. Now, infinite solutions only come from if it's the same type of function. So, exponential and linear cannot have infinite solutions. They can have no solution, but not infinite because it's not the same type of function. All right. Any questions on using Desmos to solve equations? All right. Now we can use Desmos for what we're pretty much used to, which is the graphing side. So the second way we can use Desmos is obviously for graphing. Now, you can graph an equation in Desmos and then answer questions such as what x-intercept is, y-intercept is, slope, whatever. All right. Typically, you want to do this one, especially if it's in slope-intercept form, but also if it's not in slope-intercept form and they're asking you, okay, what's the slope? All right. So let's say we had an equation in standard form. All right. You would literally type it in exactly as you see it, including what's on the other side of the equal sign. And then we can use it to find its x-intercepts and slopes. So remember, the x and y intercepts are already graphed. Now, what I like to tell you guys is find nice happy points to find the slope, meaning that they cross at right on the grid lines. So it's a little hard to see at my screen, but the x-intercept is a pretty happy point, all right? Because it's on the grid, it's no fractions, no decimals. But the y-intercept, not so much, just because it's a decimal. So if you want to do rise over run, find another happy point. So another happy point would be right here at not -4, at 5, -4. Because it's perfectly on the grid. And yeah. So then from there, you can do rise over run. So you go up 1, 2, 3, 4, over 1, 2, 3, 4, 5, 6, 7, 8. So up 4 over 8. So if we have rise over run 4 over 8, that means our slope is what? If we simplify that. So 4 over 8 simplifies down to what? 1/2. Now, would this be a positive or negative slope? Negative, because it's decreasing. So that would be our slope. So find happy points, and that gives you the slope. So they already said x-intercept is -3, y-intercept is -1.5, slope is -1/2. Now, what I want you guys to do is for all of these, so A, B, C, and D, I just want you guys to find the x and y intercepts. All right? So for all of these, find the x and y intercepts. And remember, I will call on people, so everyone needs to do this. So take a minute, graph all of these, find the x and y intercept. Guys, make sure you're putting this into Desmos, not fooling around. So everyone needs to attempt putting it into Desmos. Now remember, if it's not a linear graph, they may have more than one x-intercept, especially if it's quadratic. Mm-hmm. Mm-hmm. See, this is just so as long as it's on the x-axis, it's fair game. Everyone should be finding the X, Y, So guys, make sure you're taking this seriously because I'm telling you, this will be a lifesaver on the EOC. All right, thumbs up if you're ready. All right. James, give me the X and Y intercept of letter A. Good. So X intercept is 8, Y intercept is -4. Let's go. Neely, what's the X and Y intercepts for B? All right. Olivia, X and Y intercepts for B. Good. So X intercepts are -1 and 3. There were 2. Y intercept is -3. All right. Let's go. Kyrie, X and Y intercept for C. What? Okay. Addie, X and Y intercept for C. Good. So X intercept is -2 and 2. Y intercept is at 4. All right. Last one. Riley M. What's the last one? Yep. All right. So, guys, you gotta do it. It's not an option. So, you gotta do it. This is for your benefit. Otherwise, I can just give you a bunch of delta math and say, have at it. All right. So, those are exactly the answers that I got. So, we've talked about solving equations, we've talked about just basic graphing in general. Now, another thing that you may be asked is finding the maxes and the mins. This is specifically with quadratic graphs. So we did a lot of this back in Unit 8. So finding max and min values, again, you do a lot of that in Unit 8. So remember, max and min, what's another name for that point in terms of quadratic graphs? Who remembers from their vocabulary? A max and min of a quadratic graph is also referred to as the what? So we did a lot of vocabulary last week. The point that's referred to as the maximum or the minimum of a quadratic function is also known as the what? Starts with a V. The vertex. All right. So a lot of times when you deal with max and min, you're dealing with anything quadratic, and specifically it's the vertex that we're finding. So when you're finding the max and the min of a quadratic, again, it's going to be typically in a quadratic function. Exponential and linear graphs, you don't really have maxes and mins. It's really only quadratic functions. So this is the one that they graphed. Now, does this graph that they graphed here, is that going to be a maximum or a minimum? It's a minimum. So this is a min. Now, when we're talking max and min, all right, if they're asking for the max or min value, we refer to the y value. If it's talking about the value of x, is there a minimum? That's when you use the x value. So that's typically how they'll state. So at what x is there a min? And if they just ask for the minimum value, they want the y value. All right. So literally, just like with the x-intercepts and y-intercepts, Desmos will already have the point for the maxes and mins graphed for you. So all you got to do is click on it. All right. So that being said, I think you guys know where I'm going with this. Take a minute for all three of these. I just want the minimum and maximum value, so I only want the y value. All right, so all I want is the y value. Now, guys, before we even do that, just as review, how do we know without even graphing it whether it's going to have a max or a min? What part of the what? What part of the x squared? What makes it? So a quadratic graph is always going to have an x squared. But what part of that tells me if it's a max or a min? The negative. So if it has a negative in front of the x squared, is it going to be a max or a min? Max. If it's positive, it's going to be a what? A min. All right. So this won't be a max, max, min, and max. All right. So go ahead and find the other points. Well, not the points. I just want the y value. Remember, I only want the y value because we're just looking for the minimum or maximum value. So again, we only want the y value. Yes. All right, thumbs up if you're ready. All right, so let's go with Neely. What'd you get for A? 9. Good. Riley E, what'd you get for B? 10. Good. Olivia, what'd you get for C? -9. Good. And Lysandra, what'd you get for D? 14.25. So if you put the whole point, that's fine. But just remember, if it just asks you for the minimum or max value, they want specifically the Y value because that's the highest value on the graph. All right. We're almost done, guys. Now, the next part you should be very familiar with, which is finding solutions to systems of equations. So, guys, the inactive, you got to know how to solve it by hand. But if you are given a system of equations in the active section, you should automatically put it into Desmos. All right. Now, not doubting your math skills. Like if you can solve by hand, go for it. But if you put it into Desmos, there is less room for error. All right. So if you see a system in the active section, put that sucker into Desmos. Now, it's not always easy. Sometimes you have to write them from word problems. All right. So a large pizza, Cronies Pizza, costs $6.80 plus additional 90 cents per topping. The cost at Guido's is $7.30 plus 0.65 cents per topping. And wants to write an equation to represent the scenario and then state how many toppings would be needed for both large pieces to cost the same amount. So this first system is for Cronies. All right. Because if you think about it, y has to equal 0.90x because that's how many it is per topping. So if x is equal to the number of toppings, plus 6.8, which is our flat rate. That's just how much the pizza costs. Now, Guido's is right here. And again, 65 cents per topping, so that's why it's connected to the x plus 7.3. Now, we're going to put it in Desmos just like we did when we were solving equations. Now, based off of what they wanted, so here's my point of intersect right here. It's the point 2, 8.6. Based off of what they wanted, which one tells us the number of total toppings that we need to have? The 2 or the 8.6? The 2. So the x value is the number of toppings in this case. What do you think the y value represents? So look at the question. Talked about the number of toppings, and then what was the other part of the question? So how many toppings would be needed for both large pizzas to cost the same amount? So if x represents the number of toppings, what does y represent? The cost of the pizza. So if they both have 2 toppings, that means the cost of the pizza is $8.60. All right, you got to know how to do this. So this one, we're going to do a couple more together just so this is a review on systems and how to write them from word problems. All right. So remember when we broke down word problems last week? Remember that? How we did with the grass? Same thing. All right, we're going to do it just without the table. So let's do this first one together. So we're going to read it first. So the length of a rectangle is equal to triple the width. The perimeter of the rectangle is 84 centimeters. Write a system of equations to represent the situation, then determine the width and the length of the rectangle. All right. So first things first, we're going to go through the grass method. So G stands for given. What am I given? Someone raise your hand and tell me one piece of information that I'm given. Olivia. Say it again. The perimeter of the rectangle is 84 centimeters. All right. What's another piece of given information? Someone else. Neely. Wrong problem. Letter A. Got that already. That's fine. The length of the rectangle is triple the width. All right. So that's our givens. Now, we need to know what's required of us. What are we trying to find? Someone different. The width and the length of the rectangle, and we also want a what? A system of equations. All right. So we need the width and the length of the rectangle and the system of equations. That's what we're trying to find. So now we're going to analyze how we're going to do that. So by analyzing, we're going to first set up the system. That's going to be part of our analyzing. So the first thing with our analyzing is that we want to establish our X and Y values. All right. We just want to know what they equal. So let's start with the Y value first. So remember, Y, what's another name for Y value? This is review from your vocabulary. There's one word that describes a Y value in terms of equation. Range is one. Not quite what I'm looking for, though. Output, that's what I'm looking for. So Y also means output, meaning it's what we're getting out of our equation. So if we're talking about the perimeter of a rectangle given its length and width, what do you think the output would be? So think about it logically. If you were given a rectangle, you're typically given the length and the width, and they say, okay, find the perimeter. What's your output? The perimeter. So Y is going to be equal to your perimeter. Now, X is your input. So that can either be your length or your width. Based on what you're given, the easiest way to figure out what you're given is based off of which side length they're talking about written in the other version of the side length. All right. So which side length is what we're typically going to be writing our equation in? So in other words, is length going to be written in terms of width, or is width going to be written in terms of length? Length is going to be written in terms of width. So X is most likely going to be our width. All right, so we've defined those two. Now, the next part of our analysis is, what is typically the way you find the perimeter of a rectangle? So if we're finding the perimeter of a rectangle, how do we find it? Add all sides. All right. Now, we got that done. So if we know that Y is equal to perimeter, we know Y is equal to what? What's the perimeter of the rectangle? What they tell us? 84. All right. Now, we know the width is X. But we also need to know what the length is. So what they say the length is in terms of the width. Triple the width, right? So how do I write that as an expression? What does triple mean? So if you triple something, you're doing what operation to it? Multiplied by what? 3. So this would be 3x. So length is 3x, width is just x. So this is my first part of the system. What do you think my second part would be? Y is equal to what? How do I find the perimeter again? Add up all the sides. So this will be 3x plus x. Am I done? Am I done with that equation? No. What do I have to do? What am I missing from this equation right here? So if I have a rectangle, length is 3x, width is x. Did I add up all the sides? No, I only added up 2, so I need to add 3x plus x again. Now, you can simplify this equation if you want by combining like terms. You don't necessarily have to. You can put, as long as you get to here, you can easily put that into Desmos. But if you wanted to simplify it, you could say y is equal to 3x plus 3x is 6x, plus another 2x is 8x. It doesn't matter. All right, but you can also just put this straight into Desmos. So that's our system of equations. So these two values right here is our system. Now we're going to put it into Desmos. So in Desmos, in their own thingies, I'm going to put in y equals 84 and y equals 8x. And then I'm going to zoom out some. Click on the intersection. Which point do I care about? X or Y? What they ask us to find in the question? They want us to find the what? The length and width, right? So what do we say the width was? X. So what's my width? 10.5. So if my width or x is equal to 10.5, what's my length? How do I find it? Multiply that by 3 because 3x is equal to the length. So you can just type that into Desmos on its own. So 3 times 10.5, 31.5. All right. Are you guys... So how do you guys feel with the system part? I know it's probably one of the harder parts. So the hardest part is the setup. So problems like these, the hardest part is the setup. All right. After that, you can just throw it into Desmos and get an answer. Yes. I'll let you go on break right now. Okay. So go ahead and go on break. We'll come back and we'll finish up these problems. So I need y'all back in here by 8:50. Get an extra 2 minutes.
I love the slipper. Yeah, I know. We were talking about that.
Wait. How do I erase it?
The eraser at the top. Oh my god, let's go.
Wait. Okay, there we go.
Why are you? I was looking. I passed by. You asked where's my uncle, so I answered you. Shut up. Hey, don't talk to him like that.
Okay. Okay.
No, that's fixed.
Shut up.
Oh my god.
Why do you do that?
Are you messing up the camera?
No, I'm not listening.
Where you are? Oh my god.
Oh, fuck. I'm gonna go. Ralph, touch your reader. You're too big, so I can't finish.
Why?
Sorry. Oh!
Don't talk to him like that.
What did I miss?
No. Alright, will.
You have no evidence to back your story.
Right.
Go,
I'll
please.
kill you. It's either your butt or your foot.
I just got right.
18, 14. I think it's pinch your finger. Alright.
Hey!
I'm gonna pinch you.
Oh my.
I didn't even take it. No, I didn't. I missed. I ear was back. No. You saw it.
All right, guys, let's go ahead and get back to it. So, let's see if we can figure out the next part. All right, so part B. So, a restaurant, the cost for a breakfast taco and a small glass of milk is $2.10. The cost of 2 tacos and 3 small glasses of milk is $5.15. Write a system of equations to represent the situation, and then find the cost of the small glass of milk. All right, so going through graphs. What's our given? Someone raise your hand and tell me one piece of given information. It's what? 3 tacos or 2 tacos and a small glass of milk is $5.15. What's the other piece of information? Olivia. Right, a singular taco, small glass of milk is $2.10. So that's our given pieces of information. Now let's look at our required. So what are they asking us to find? The cost of a small glass of milk, and they also want a system of equations. All right, so that's what they want. Now, let's do our analysis. So first things first, whenever you do an analysis with systems, you want to define your variables. So something's going to be X, something's going to be Y. So remember, when you're talking about X and Y, you're looking at what they're talking about. All right. So what are the 2 things that they're talking about here? They're talking about, what about the tacos? Are they talking about the number of them, or are they talking about their cost? Their cost. So let's say X is the cost of a taco. Shh. All right. So what does Y have to be? What's the other thing that they're talking about? Shh. What about the milk, though? They only care about the cost of the milk. So now we can write our system based off of that. So let's go based off of what's highlighted in green. So a singular taco and a glass of milk is $2.10. So the first thing you want to figure out is what goes on the other side of the equal sign. That's where the is. So wherever you see the word is, whatever follows it is on the other side of the equal sign. So what are we equaling to at the end of this? What do we want our equation to be equal to? $2.10. That's our total cost for the entire order. Now, we had a singular taco and a singular glass of milk. So how would I write an equation to represent that cost? Using what I just defined as my variables. X plus Y equals 210 because you have a singular taco, so you're only paying the price for one, which is X. A singular glass of milk, so you're only paying the price of one, which is Y, and you're saying it equal to 210. So that's the first part. Now, the second part comes from your yellow highlight. So, what's it all going to be equal to? What's our total? So, what's our total? Look where the is $5.15. Now, how do I represent the cost of 2 tacos? So X is the price of 1, 2X is the price of 2. So 2X represents the cost of 2 tacos, plus, how do I represent the cost of 3 glasses of milk? 3Y. Good. Because if you think about it, if you go to Taco Bell, you buy a taco, this is not the price currently, but if you buy a taco for $1, all right, if you bought 2, you pay $2. All right. Now, this is what we're going to put into Desmos. You're going to put it in exactly. So you're going to graph that in Desmos. So go ahead and put both of those into Desmos. Find the point of intersect. So x plus y is equal to 2.10. 2x plus 3y is equal to 5.15. Now, it may be super zoomed out, so hit the home button and it'll zoom it back in. Now remember, what did they specifically want me to find? What? The price of the glass of milk. Now, given that point of intersect, which part's the price for the glass of milk? The Y value. So how much is the glass of milk? 95 cents. Now, if they asked us what the price of the taco is, how much is it? $1.15. All right. So that's when you would go back to your variable. So our answer would have been 1.15, 0.95. And since we want the cost of the glass of milk, that comes from here. So our answer is 95 cents. All right. Now, let's do part C together, and then I'll let you do part D on your own. So part C, Marcos has 15 coins in nickels and quarters. He had 3 more quarters than nickels. Write a system of equations to represent the situation. How many of each coin did Marcos have? All right. Now, this one isn't too bad because it actually doesn't talk about like the total amount of money. But remember, a lot of times with coin problems, you are talking about the total amount of money somewhere in there. So just to recap, how much is a quarter worth? How much is a quarter worth? 25 cents. How much is a dime worth? 10 cents. How much is a nickel worth? 5. Penny? 1. All right, you need to know that because they will throw those questions at you. Now, going through the graphs, G is given. What's one piece of given information? We have 15 coins total, and that's in nickels and quarters. What's my other piece of given information? Someone different. 3 more quarters than nickels. Now, that's our G. Let's go to R, which is our required. So what's my required information? We want a system of equations. What's the other thing that we want? How many of each coin do we have? All right. So now we're in our analysis. So let's start by saying what our variables are. So what are we talking about here? What's going on in this situation? Now, I'll give you guys a hint. A lot of times your variables are going to be based off of what the question's asking. So what is the question asking? How many of each coin? So what do you think X and Y are going to represent? So if we're talking how many, we're talking about a what? So how many means the blank of each coin? The number of each coin. So we know there's going to be a number of something for both of them. So what do you want X equal to? The number of what? Let's say quarters, all right? Doesn't really matter which one we pick. Let's say nickels for this one. You'll see why in a second. But it doesn't matter. You could have done quarters. So that means y is quarters. So now let's talk about the system. So going through our required pieces of information, the first one, or the green, 15 coins in nickels and quarters. So how do you think I would set up that as an equation? So how many coins do we have total? X plus Y equals 15, good. So the number of nickels plus the number of quarters equals 15 coins. Now, our other piece of required information states that we have 3 more quarters than nickels. So if we're talking about 3 more quarters than nickels, that means, how we write the number of quarters in terms of nickels? So which variable represents our quarters? So y equals what? So if I have 3 more quarters than nickels, if I had 5 nickels, how many quarters do I have? So guys, if I have 3 more quarters than nickels, if I have 5 nickels, how many quarters do I have? 8. If I have 9 nickels, how many quarters do I have? 12. So how are you finding it? So how do we get from 9 to 12? Add what? 3. How do we get from 5 to 8? Add 3. So what do you think I'm going to do here? Y is equal to what? X plus 3. The number of nickels, and you add 3. Does that make sense, guys? All right. Now, put both of these into Desmos and get the point of intersect. So graph both of those equations in Desmos. Give me that point of intersect. All right, someone raise your hand and tell me what their point of intersect was. Ralph. It was what? 6, 7? 6, 9. So that's our point of intersect. So based off of what we described as X and Y, how many nickels do I have? 6. Because what value represents our nickels? X. So how many quarters do I have? 9. Because of this part right here. All right, so what I want you guys to do, I want you guys to try that last problem on your own. So try that last problem on your own. So go through the GRASS method. Find your given, find your required, analyze it, solve it, and then state your answer. Mm-hmm. All right, so go through the GRASS process first, like we've been doing. Find your given and find your required, and then try the analyze part. So do that first, and then I'll help. Okay. So read the problem first, and then figure out what you're given, what information is important.
Benjamin, stop. What happened?
Quickly.
So based off your problem, what were you gonna? What's important? We gave them, we gave. What's the other? Oh. How much required? Right. So now we're in the analyzing point. So that's where we're figuring out what our variables are representing. And then we say this is. So this is what goes. Let's talk about inputs, what you're putting in, what you're getting out. So inputs usually represent values and values are like. Wait. X. So what are you putting in? So in other words, the number shows. So X, I would say X is what the number shows. Now, what's coming out of the equation? Or how much would it cost? So Y is equal to the cost, or total cost. So you're gonna have two different equations to represent how much that total cost is going to be depending on the equation. So your first piece of equation, how would you write an equation statement? Just think about it. It's gonna be equal to your total cost. You're gonna start with a y equals zero. Now, some of these will be one here is that like inflation. It's a flat fee. So that's what you like pay the company upfront, and then it's $9.65. So if it's $9.65 per shirt, that means if I got two shirts, I would do what? Figure out the price of that.
Those and companies and then peelable gums. Regular Fuego. Yeah, regular Fuego.
They used to back in the day, which was.
Regular.
Just type that. What's your flat rate? So now you're gonna set up your second equation pretty much the same way as the other equation.
You did.
Uh-huh.
So far. The environment.
I would say the Y is the total cost.
Oh.
Remember, you're trying
We did it.
so remember, when you're trying to make equations like this, think about just input output. What are you putting in, what are you trying to get out? So you put in the number of shirts, you get out, the total amount.
Is this the last one or are you doing something?
We'll do that tomorrow. All right, guys. So just for time's sake, I'm going to go ahead and go over it. So this is what I got, and you can check your answers. But if you went through the grass process, your given was one company charges $9.65 per shirt plus a setup fee of $43. The other given would be another company charges $8.40 per shirt plus $58 fee. Your required is they want the system of equations, and they want how many number of shirts would you need for the prices to cost the same. So with your analysis, the very first thing you should start with your analysis is defining your variables X and Y. So if you had trouble with that part, think about it in terms of input and output. What are you putting in and what are you trying to get out? So when you're thinking about what you're putting in, basically what you're putting in, like think about like in a website, like if you're trying to buy something, all right? You typically put in the number of the amount of item that you want. So what you're putting in is the number of shirts. What you're getting out of it is your total cost, all right, that you pay the company. Now, the way you set up your equations is however much it costs per shirt, that's what you're multiplying to X. And then the setup fee is just a flat rate, meaning you pay that up front regardless. So the first equation would be 9.65x plus 43, y equals 8.40x plus 58. Now, when you plot that in Desmos, you should get the 0.12. What was the y value? I don't remember the y value off the top of my head, but the x value should have been 12, and that represents 12 shirts. All right. Any questions on that one? All right. So we're not done yet because we do have your math minute. All right. That's the last thing we're doing today. So go ahead and close everything. Hold on to that packet. We're going to finish the last part of it tomorrow. All right. So we're going to go ahead and do y'all's math minute, and that'll be the last thing we do today.